Serge, I guess just logistics as my screen share coming through. Okay, can you see
Yes.
the slide?
Yes.
Perfect. So let's go ahead and advance it and jump in. As Jared said, Leo Vasilou, and I would consider this to be a very targeted, focused, crisp, efficient webinar. Really, all we're going to do is break down some key concepts to make sure we're talking about the same thing. We're all on the same page. We are very excited to do a live demonstration to see those concepts in action. Then a few words on the what comes next, because it's not a one and done. Serge, did I miss anything? Do you want to say anything about yourself before we continue?
No, I'll just add that yes, excited, but of course with live demos, right, there's all sorts of trepidations, but absolutely excited.
Agreed. So intro and concepts, like I said, just to make sure we're talking about the same thing. Before we jump in, let's just take a moment before we level set on the concept. Serge, why have this talk at all? Well, in my opinion, I think it's because the products and services that our companies and organizations sell generate the revenue that pay our rents and mortgages. So we need to ensure reliable CICD so we can remain competitive and pay said rents and mortgages. But unfortunately, that messaging didn't get approved during the review cycle. So Serge, maybe you can tell us why we're here, why we're having this talk at all.
So I think we're going to repeat it a couple of times today, but complexity, dependencies, right? The internet's a very complex place, and you don't own most of the services that you operate. So it's really important to understand what's going on so that the ones you do work the right way.
Yeah, and so these are some of the things that we hear. So we have the fortune of being able to talk to our customers, right? So take any one of these, because there's really one main thing here, aside from the words on the screen, and that is IT and the business must be partners, right? They must align. So take any of these flakeable, that's the combination of flaky and unreliable. Flaky, unreliable automations, like, oh, IT is like, oh, it's going to increase our manual work, increase risk, increase tech debt. Whereas the business is saying, that's going to be a higher chance of releasing bugs to production, leading to customer satisfaction, right? Dissatisfaction. But regardless of what we have here, so lack of visibility, can't connect, can't even do our work, siloed tooling, telemetries, that's the I'm not seeing this issue on my end conversation, or it worked fine in the cloud, but the business is saying it's not working fine for the users. The main takeaway here is that IT and the business must be partners, must align on the goals and what is important.
And of course, the flip side is also true, right? The business side may say, hey, if you do this, there's a higher chance of customer dissatisfaction, or they might not connect the dots, and then it's up to the IT practitioner to remind the business what it is that they care about, right? Hey, we need the budget for these things because otherwise ...
Nicely said. All right, so let's continue on here and get to some of those concepts like we were discussing. So resilience through chaos, integrating internet performance monitoring, IPM, into your observable software development lifecycle, OSDLC. So let's break this down to make sure we're all thinking of these terms in the same way. It starts with the internet stack, which is the collection of technologies, systems, and services that make possible and impact every digital user experience. And it's an entire chain of components, from core protocols like DNS and BGP to platform providers like your APN providers, your CDN providers, across points of interconnection, and all the way out to the last mile, home and residential ISPs. It is separate and distinct from your application stack, and the internet stack is different for different users in different parts of the world. And I like to think of it as, if your application stack is what generates the code, the internet stack is what gets the code to the users where they are in the world. Having said that, what is internet performance monitoring? For us, it is about visibility into that stack to catch issues across your customer base, your workforce, your applications, your networks, your websites, before those issues impact your business. And in order to do that, we have to preserve these 4 critical properties of the internet stack despite adverse conditions, the truest, shortest definition of resilience. So resilience through chaos, integrating internet performance monitoring, or IPM, into your OSDLC. And Serge, I think maybe people probably already have an idea about like uptime, availability, performance. Is it fast or slow? But real quick, just to kind of talk about reachability, if you want to help me out here. But I think of it as, what good is a brightly burning sun if its rays cannot reach you on the beach on a cloudy, stormy day? That's my go-to analogy. What good is a highly performant, highly available cluster of services in the cloud if those products and services cannot reach users wherever they are, whenever they are, right?
Yeah, absolutely. And again, the flip side, right? So yes, can the service reach the users, but probably more importantly, can the users reach the service? And so as a developer, as a product manager, product owner, our goal is to make sure to think about, where are all of these various people using our product from, and make sure that we think about the reachability of those customers, of those users, to the applications we're delivering.
Mhm. And Serge, since you've got the microphone, maybe you could kind of talk us through the other key concept.
Yeah, absolutely. So I'll talk about CI/CD in a second. The other thing I just wanted to say is the IPM monitoring, let's call it KPIs, are going to be different for different people. So just like in CI/CD, there are different stakeholders uh, that are involved in different parts of the software development lifecycle, right? And so we have this as the CI/CD sort of continuum. It could be the SDLC or OSDLC continuum. It could be the software development pipeline, different names, agile, different names for the same thing. But if you would skip to the next one, please, Leo. The goal is to make sure that you and all of the various stakeholders are thinking about all of these things. In particular, is the application working properly along the whole way? And we've talked about this in previous sessions, but from the very planning phase, where you're kind of defining your IPM strategy, what is it that I care about, right? Do I care about just people in New York where I'm located? Do I care about people in, let's say, Tokyo? Do I care about speed, or do I only care about availability, right? All of these different things, turn them into business KPIs, or rather take the business KPIs and convert them to the observability, the IPM strategy. And then that flows through the rest of the CI/CD process here, right? Applying IPM as code, well, that's where integrations and APIs come in, and I'll show you that in a second in the demo. Dependency analysis, super duper important, has to be done. And then, of course, the feedback loop, right? How are you making sure that everyone along the way is using the same KPIs, is monitoring the same way, and that you're improving the system as it changes?
And what I'll add here is we have conversations about, shifting left or shifting right. And this webinar is really, I guess, the idea about doing both, shifting wide, as we have coined the term. And that is to kind of integrate IPM through the entire life cycle. I'm very excited for the demo And so we'll just kind of talk through this one last slide here before we hop right in. So resilience through chaos, right? So we've talked about internet performance monitoring. We've talked about CI/CD. Resilience through chaos, embedding into your entire CD. What is resilience through chaos? So we are talking about the idea of chaos engineering to ensure resilience. The caveat there is, in addition to just injecting complete failures, that injecting performance degradation is damn nearly as powerful and effective for these chaos experiments without actually bringing the system down.
Yeah.
So kind of take that as a critical way to think about, because in my opinion, calling something chaos engineering probably on paper does not sound like a risky thing that a layperson in the business who holds the budget would be like, yeah, let's do some chaos.
Yeah, exactly. The quote unquote real way, or the original way to do chaos engineering, is to walk into a data center and pull a wire and see what happens, right? Nowadays, probably not too many people doing that. But what we're going to walk through with the demo is you could actually do exactly that without impacting the application that's really running in production, but then still seeing what those, chaos results would be.
The downstream effects, right? So you've got, and all we're trying to say here on this slide is like you've got all your things on the left, all your inputs, all the components of your application, what it takes to get those experiences to your end users. And will the output be good? That is the top, or will it be bad? That is the bottom.
Yeah,
that's what we aim to answer with chaos experiments and the broader resilience testing practices. And excuse me. So, what's that expression? I don't fail. I learn what doesn't work and then try again, or I don't fail. I only win or learn, or whatever it is. Right. So what we're trying to say is that each of these experiments kind of adds to your shield wall. Like I said, a type of what doesn't kill you makes you stronger, believe. And there's only one piece missing, right? That is you, the people who are giving us your precious time today and listening to this webinar, watching this recording.
Yeah. So let's jump right in.
Let's jump right in. So we'll go ahead and I'll stop sharing these slides. We'll have Serge share his screen and see these concepts in action. So
absolutely.
Serge, good. I see demo app. It's coming through fine.
Yep. All right. So what are we going to talk about first? So we're going to do kind of the two halves of this demo, the same way that Leo just talked through the introduction slides. And that is, first, we're going to create an application and we're going to set up a observable SDLC around that application. Everything's going to be working wonderfully. And then we're going to break it by applying chaos engineering to see what actually happens when we start playing around. So the application itself, we have this super simple application. As you can see, it loads an image, it says demo app, and there's a button that says call backend. And when I click that button, it pops up a message. So there actually is a back end application to this front end, which returns this message. And the last change that was committed against this application was several days ago on June 19th. So great, super simple application. So the first thing to do when designing an observable SDLC is let's think about what the dependencies are. And this is kind of interesting, just my own personal experience setting up this demo. I started doing the dependencies on paper, and then I said, okay, that's silly. Let me do it using Visio. And then it got too complicated. And so I said, wait, this is entirely too silly. Let's just use Catchpoint's stack map. And so Catchpoint has this great diagramming visualization feature called Stack Map, and that is not what this webinar is about, so I won't dwell on it, but here is what I created. And so you see here that the application itself, well, you don't see this here, but the application itself is a React front end with a Node.js backend. It's running in AWS. It has dependencies on DNS, and it has dependencies on that big image with the dots is loaded from actually the Catchpoint corporate website, which runs using Webflow. And so that's a dependency. So great. I went and drew all of that out, right? And I like to think of these things as what is the data flow for particular users? And so as a customer, I would go to this demo application URL, which then goes to Cloudflare because that's the CDN, which then sends me to a front-end load balancer. The front-end load balancer, by the way, uses Cloudflare DNS for the domain name lookup. The load balancer sends me to the front-end application itself. All of these four are Docker containers. The front-end application loads or interacts with the back-end application through a load balancer, and it has this dependency on Webflow, which we already talked about. Right, so such a simple application. Again, literally, it's a screen with one image and a button.
And, Serge,
and this is what you see.
Yeah, I was just going to say, I don't know if that's where you were going with it, but what I saw is that if you go back to that app, you don't have to, but an image with a button to click may seem like fake, right? But the architecture, the modern architecture that you were talking through with that service map of your front end components, that is very real.
Yeah,
so
absolutely.
We ask to not be fooled by the simplicity of the application, but that the underlying architecture and set of stack components, what we talked about, is in fact what an architecture might look like, multiplied times the complexity, scale, magnitude of whatever your actual applications, products, and services are.
Absolutely. And I mentioned earlier that I like to think of these as from the point of view of the users. Well, guess what? One of the other users or stakeholders of this system is the developer, right? And so the developer interacts with this system using GitHub Actions in this case for the demo. And so GitHub Actions actually is what launches or updates all of the containers. And it needs to interact with AWS because that's, of course, where these particular containers are running. And so there's dependencies on all of that. So what happens if any of these dependencies go down, right? So this is kind of the next phase of the analysis. Well, first of all, some of them are production system dependencies, some are tooling dependencies, right? And so if Cloudflare, for example, has a hiccup, your users are not getting to your application. Maybe that's okay with you, maybe it's not. You still want to know about it so that you can decide what to do if a problem does arise. If DNS has a problem, same thing. Webflow, okay, we can test that with Chaos Engineering. All of these things, as you go through the dependencies, you need to say, okay, do I care if this thing is slow, unreachable, not available, right? So go through all of those pillars of resilience and decide if they're important to you. And that's how you come up with your main KPIs. So let's move on to the observable SDLC piece. So
indeed.
One more comment actually before we do that. The dependencies here, usually you would have your application, you're applying monitoring to it, and the stack map will actually pull all of the dependencies and draw as many boxes as it can. In this case, I used it the other way around, sort of like the TDD, test-driven development methodology, where you write the tests first and then you write the application. I drew the stack map and I said, okay, this is what I have in my mind. Let me go and develop and create the monitoring strategy for this application. So that's what we're looking at.
Makes sense.
All right. So the pipeline, relatively simple, but pretty powerful pipeline. So what it does when somebody makes a change on the develop branch, I have two branches, develop and main for this demo, is it runs unit tests, then it deploys to the staging environment, then it runs web page tests. So web page test is one of the pieces of Catchpoint geared for web page performance. So that is more often than not used by web developers as opposed to other pieces of Catchpoint which are used by site reliability engineers. So again, we mentioned before, which metrics people care about is going to depend on who they are and what stage of the software development lifecycle they're in. And so what web page test does is measures all of the relevant web performance information. For this particular GitHub action, I have it doing something pretty simple: measure these 4 metrics because they're important, and make sure that they are all below the Google recommended thresholds. Cool. So that works. It's wonderful. This particular commit, the unit tests passed, the web page test run passed, and so it actually goes and creates an automatic pull request for the production environment, which then a human can take a look at and merge to deploy to production. But what happens if the web page test doesn't pass? So one of those metrics is largest contentful paint. And as you can imagine, with this demo app, this image is actually the largest contentful paint. So whenever that image comes up, that's the time in the timeline that that LCP occurs. So what I did just to for the demo is I delayed the loading of that image by 2.5 seconds. And so it just so happens that Google's recommendation for LCP is 2.5 seconds. And so in this case, of course, by delaying it, LCP happened at about 3.5 seconds. And so this pipeline automatically failed and said, hey, you know what? You are not passing the web page test KPIs requirements that are part of this development process. And so it won't be automatically create a pull request to push it to production. So that's the development half of the OSDLC. The second half is the site reliability half, right? So now we take an application, it's been tested, everything is working wonderfully. Let's deploy it to production. Oh, and by the way, let's create these templated Catchpoint schedule tests so that we know while the application is running in production, Catchpoint is watching it to make sure that everything is working properly. And so same thing, integrated into GitHub Actions. And in this case, it checks to see if the tests already exist, because if a new application is developed, we need to create new tests. This application already existed, so it skipped the create new steps phase. All right. And so here is what gets created. So this is just my personal philosophy. Of course, different people do different things, but for a web application, I like to have at least a quick HTTP web-based test that's just running very often from different locations where I expect users to be. It also runs traceroute just in case there's a problem to see if the problem is network related. Then I want to make sure I test any of the important dependencies, in this case DNS, as we talked about with the stack map is an important dependency. And then I want to do a less frequent but more in-depth end-to-end test of the application. And so I'll show what that is in a second. So here we go. So this is the quick HTTP test. Everything is working wonderfully, no problem. It kind of gives you an overview. I won't go through the details. That's a more in-depth Catchpoint demo, but this is the quick test. This is the DNS test, right? So I'm showing different screens here, but for example, this one is a scatter plot. And what's interesting about this is you see the data is kind of spread out. So one thing we can do maybe is actually break it down and start analyzing what's going on here. Hey, it looks like, interestingly enough, the Tokyo DNS experience is actually better than the US DNS experience from New York and from San Francisco, right? So
You
you would
sound
think
surprised.
further away, but it just so happens that for this particular domain, it's actually faster. And of course, in this case, 5 to 15 milliseconds or 5 to 20 milliseconds, it's not a huge difference in either case, but it can be a very big difference.
Well, it can be a very big difference when you consider a typical user journey probably has hundreds and hundreds and hundreds
Absolutely.
of individual request components, each with their own individual time. So when you add it up, that 20, all of a sudden is milliseconds is all of a sudden,
Yeah.
2, 3, 4 full seconds. So it adds up.
Absolutely. And this is where that site reliability engineering comes in, right? So the application itself is working fine in this case, but can we improve the performance, or can we notice where there might be some hotspots and then focus on those hotspots? And so these breakdown tools are one way to do that. So skipping along, I mentioned there that we set up this more in-depth test. Well, the more in-depth test is actually launching, in this case, Playwright, which launches Google Chrome and clicks on the button, right? So that's the only user journey for this particular demo application. But you see here, okay, at the very beginning in step 1, you see our demo app and the button has not been clicked. And then when I click on the third step here, hey, look, the screenshot shows that it has in fact been clicked. And you can, of course, measure all of the performance along the way and break it down and say, hey, is just the first part working properly? Is the interaction with the backend working properly? Really dig into what the most common flows of your users might be. So that is how you set up the OSDLC in the first place, right? So just super quick reiterate. You have your, in this case, GitHub Actions, could be Jenkins, it could be anything else that is measuring the KPIs that are important to your business. For developers, I said it's the core web vitals measured through web page test. For site reliability, I said, okay, we care about DNS, we care about web performance, we care about the user journeys, and those tests got set up using Catchpoint's APIs. So now let's break things, if you're okay with that, Leo. So
I am okay with that.
So for Chaos, what I figured is, okay, well, you should always have a baseline performance. And then you can do, of course, many more things, but I thought it would be interesting to test these 4 different scenarios. So let's just walk through them. So the first scenario is, I had it in the stack map, but I didn't talk about, there's a CDN, right? So we're using the Cloudflare CDN. So does it actually improve performance, in particular for different users? So I'm running this service in AWS on the East Coast. I'm located in New York, so I said, hey, let's also test from New York. Let's test from San Francisco, and maybe wishful thinking, but maybe we have some users in Tokyo. And so we see here that, hey, the baseline, the people in New York, as you can expect, are having a relatively good experience. And it's pretty comparable to the experience for the CDN. But if we look at San Francisco, okay, it's getting worse. And if we look at Tokyo, as you could expect, the distance from the origin server, it's getting much worse. And so, in fact, the CDN does, as you can imagine, have a massive performance improvement. So then let's look at bandwidth. So nowadays, most of our users have pretty fast internet access. What happens if they don't? Do you care? Maybe you don't, and then this is not an experiment that you would run. But if you have users accessing maybe an old DSL link, or maybe even like a 3G or 4G cell phone service, to use your website, you can throttle the bandwidth accessing the website, and then you can take a look and see what happens, right? So again, you see that, hey, if the bandwidth is throttled, yeah, performance is slower, but what is interesting is it still works, right? The site still loads. It's slower, but it still loads. And you see that, hey, look, there's my application. So the next thing I said is, hey, remember this big dependency? So just to kind of remind people, here's our front end service. It has a big dependency on Webflow to pull in that giant image, right? The hero image in the application, which is this guy over here. Well, what happens if that dependency doesn't work? So what happens if Webflow in this case is down, or the Catchpoint website is down? What's going to happen to my application? So a couple of things. First of all, we see that kind of as expected, the number of bytes downloaded is way, way, way less if we block the request. Maybe more interestingly, the actual amount of time that it takes for the website to load is pretty much the same. Cool, so that means it's working, right? Well, whoops, sorry, the wrong. Oh, yeah. So take a look at what actually happens. So it failed to load the image, which you would kind of expect, but none of the rest of the application loaded either. So again, it's important to test these dependencies, right? To make sure that, hey, if this thing goes down, what's the result? Does my application still work? And of course, in this case, on purpose, I use JavaScript to not load the rest of the application until the image appears. Not a great practice as a developer, but hopefully an effective demo. And the last example that I have. So has anybody here, and I'll ask this as a rhetorical question, ever had their maybe cough cough marketing team want to put an amazing, beautiful, high resolution logo, photo, whatever in their application or on their website without even realizing, hey, I'm putting this 10 meg file where it used to be a 1 meg file?
Well, Serge, yes, but only because it was a picture of you. So I mean,
Why, thank you. Why, thank you. I look amazing in high def, as does everyone else, of course. And so let's simulate that, right? And so here's the normal image. The normal image is about 300K. Well, let's replace it with a 10 meg image, which I'm actually pulling from Wikipedia instead of from the Catchpoint website. And so let's see what happens. So interestingly enough, the page loads just fine, right? So no issues there. It's still rendered, but let's do a records compare across the two of them. So you see there's the baseline, which is the primary run, and you see the request override. Look how much slower the application became when we added this giant image, right? So nothing. It used to be done loading at about 800 milliseconds. Now it's not done loading until 2.2 seconds.
So 3 times as much, and that's
three times as long.
an aha moment.
Yeah, exactly.
Right.
And of course, the goal here is to kind of hopefully get people to think about, ooh, that's cool. What else can I test? And remember, for none of these tests did we actually change the production environment. I guess you can kind of say for the CDN test we did, because we actually tested 2 different things, one with CDN, one without. But for everything else, we used various overrides or various blocks or various filters to change the bandwidth, to change the image, or to block dependencies, and then see what happens with the application. So that's what I have.
All right, Serge.
All right, stop
The
share.
first, thank you so much. So one moment while I get back to sharing the slides. So let's go back here, see if it picks up where we left off.
Yes, sir, it did.
All right. So demo of capabilities. What comes next? So let me just kind of park this image up here for a second. So hopefully when the AI summary occurs, it'll mark this point in time right here as like, the important moments. One is that uptime and performance, right? You don't need to walk into the server room, walk down, pull a drive out, and wonder what happens. The second is the user conditions. So when you're in your CI and you're testing from your desktop or wherever you said you were testing one, right, going to be completely a different set of data than when you inject user conditions. So we saw the demo. It was great. Thank you very much. Had a couple of aha moments. And so we want to make sure we're talking about the entire life cycle, right? The continuously simply making it better cycle. It's not a one and done, and it's not a matter of if, it's a matter of when there will be incidents. So just pause, take a moment, think through your entire tool chain, think through your entire productivity stack. It's all important. They should all be part of the conversation. Your people, your processes, and of course the tech, and we only showed a handful. Think through the dependencies, make sure incorporate into this flow. What happens if an entire portion of your team in a particular part of the world cannot work because of bad weather, right? Organizational level resilience, and so on and so forth.
Yep.
Excuse me. And then the idea again of not having to choose necessarily, of shifting left, catching issues when they're cheaper to fix, but versus shifting right, monitoring the actual user experience, but shifting wide, because we don't actually have to inject real failures. We can simulate what those failures will look like and then look at the data. Now, what comes next is kind of the closing thoughts here before we wrap it up. So if you look at this x-axis, this is a long-term trend, right? It looks like it's a few months. So what I want to say here is, let's say, day one, you're doing, you're checking your stats and hypothetically says, 95 milliseconds, 100 milliseconds, 97 milliseconds. Day two, 96 milliseconds, 101 milliseconds, 98 milliseconds. Day three, 97, 102, 99. Those daily results may be deceptively within your range, and eventually, yes, you might get that pop-up saying outside of Google's recommendations.
Yeah.
But when you look at a long term, and we might also incorporate the word regression here, we can see that slow creep, it's not something you're going to see without the continual piece, right? The SRE piece. And what we want to say here is that this gets back to what I was saying about in the real world, where you have to take external conditions, these wireless users, mobiles, et cetera, into account. The performance that you're seeing is not going to be so clustered. And when you do your continual measurements, averages lie. So we must ensure to look at performance as a distribution. So here, for example, we're looking at a bunch of different percentiles, but could be histograms, could be cumulative. Maybe think of a group of people, kids in a classroom, people on a sports team, and line them up based on height. Say, what's the average height? I don't know, 5'5", right? There's going to be people who are taller, people who are shorter, right? Same thing with performance. The average is blunt. There's always going to be faster. There's always going to be slower. And every percentile looks different. And different things will affect different percentiles. And I want to slow down for a second here and say, if there's a blip being the super technical term for micro outage, right? Very short duration, that might move the 95th percentile, or that is to say, affect only 5% of your users very quickly, versus say a full release with the heavier payload is updated. Maybe that 300K image all of a sudden goes to 10 meg on accident, like you were showing. That might move, the 50th percentile or the median. That is half of your user base is affected because they're on their mobile, in a crappy Starbucks cafe or something like that. And then one more quick example, again, just to kind of go back to that slow creep trend. So we have a long-term trend that looks like this. Notice that crazy spike on the end. And if we kind of go back to that concept of internet performance monitoring and break down by a view that looks like this, we can see that if we break this down and talk through this, so Asia looks like it is in fact creeping up. Europe, very much less so. And then North America, yeah, it definitely has increased. And then there is that crazy spike that we saw on that previous chart, which was an aggregate of these breakdowns. And we can see, hey, I really messed up something in North America. So that kind of brings us to the other dimension. Is it regional/localized versus global, right? So micro short duration incidents, prolonged sustained incidents is one dimension. Global versus regional, local is the other dimension.
Well, and the goal here is to collect all of these dimensions, cardinalities before you need them, right? Because once an incident is happening, you no longer have the baseline. You don't know what to compare to see if things got worse. But collecting all of them the whole time means you can pull up data like this and say, hey, look, there's a spike. But wait, the spike only impacted North America. It didn't impact anything else. Therefore, the root cause must have to do with North America.
Through your drill downs, go into the stack map, click on the individual components. Exactly. All right. That was the official last slide. So we're just going to offer some closing thoughts. Get ready to wrap this up. See if there's any other questions or any questions that come up. So first, thank you again for your precious time today. We talked about the key concepts to make sure we're on the same page, saw a demo of the capabilities, and then talked about some of the what comes next, right? It's not a one and done. We'll go back to what we were saying earlier. That first slide, or was the second slide technically, I guess, why are we doing this, is like, if there are problems, if there are things, different folks might react differently and be worried about different things, but they have the same goal, or they should have the same goal. IT and the business should be partners. And speaking of business, I always like to say that capabilities are the gateway to business outcomes. So if you've got your tech speeds and feeds on the extreme left side, if you will, and your business outcomes, your business goals, your revenue on the extreme right side, if you will, talking about the capabilities is what is going to help make those IT to business conversations be easier. In order to do this, we need the ability to ...
Yep.
Analytics. Yep. Analytics, data becomes information, becomes knowledge, becomes wisdom. So again, the data, right? Your individual test runs, but also across the long term to do things like check for regressions across different dimensions with different levels of cardinality, basically what's important to you. We didn't talk about this too much, except when we said the idea of shifting wide. So make sure to standardize your telemetry across the life cycle, so people aren't measuring in feet and inches in pre-prod, but using the metric system in production, right? We don't want different people responding to different things where they think one is noise, but it's actually signal to someone else, or vice versa. Even simple is complex. That crazy application surge, right? For the sake of demonstrating,
Yeah.
That architecture that we talked through in the stack map, very real.
Yeah, and I really tried to keep it simple. That was my goal. Keep it to 2 or 3 boxes, and then as I sat there thinking about, okay, what could go wrong, the boxes just kept coming.
And then slow is the new down. So please remember, you don't have to inject complete failures. You can inject, simulate performance degradations as well. Does it move the 99th percentile, 95th, etc., right? Slow is the new down. And another way of saying that is, yeah, bad performance is equally as bad as downtime. So you can test it, though, without being fully down. And then again, shift wide, standardized telemetry. You don't have to worry about the debate of shifting left, shifting right, shift wide. Use IPM to shift wide.
Well, and specifically, you can shift right now and test in production without actually breaking production. So that's the goal.